Hello Year 12 and welcome to our second video here for geometry. We're looking at the angles in triangles and polygons today for exercise 7b. This idea of an exterior angle, maybe that's less familiar, but check out the diagram here. If I extend one of the sides out, right, then I produce an exterior angle, right? And you can see that I now have a pair of adjacent angles that will be supplementary because they form a straight line or a straight angle. We've got an example here that we're going to work on. Now I'm going to look at a strategy first before I just launch into some sort of proof. I'm going to come up with a plan. Now theta is here and I need to find the value of it. And it's inside a triangle. I know one of the other sides. I know the interior angles of a triangle add up to 180 degrees. That's one thing. I also know that the exterior angle is equal to the sum of the opposite interior angles. So 35 plus theta will equal this angle here, PBC. And PBC and QCD are corresponding angles on parallel lines. So I think that's going to be the most efficient way to the solution. Let's grab a red pen and we'll start writing. So I said that QCD, the angle QCD, you can indicate an angle with a thing on top there like that, is equal to the angle PBC, and I need to say why. Why is that so? Because corresponding angles, on parallel lines are equal. Righto. First thing done. Now I might want to jump in here and put a little 110 there. Okay, just to remind me. A bit of a visual clue. Now I know that we're going to use this property that the exterior angle is equal to the sum of the opposite internal angles. So let's write that down. PBC is equal to BPA plus PAB. Now, my justification for that is that the exterior angle of a triangle is equal, this doesn't have to be word for word, to the sum of the opposite interior angles. Maybe not word for word from the notes, but clear enough. Now I'll put a therefore. Oh, actually, I feel like I should have snuck an extra line in here and said, therefore, PBC equals 110 degrees. Right, I think that's a bit neater. Now I'll put a little therefore here as well and say that theta plus 35 equals 110 degrees. Therefore, theta equals 110 minus 35, 75 degrees. Rightio. You can see there's a certain amount of explanation here in brackets that should reference our notes. Now, there's lots of things to take in here. You'll need to refer to your notes a lot. Unfortunately, you know that you can't take these into your HSC, so you do have to be fairly familiar with them if you're going to rely on them. And being able to rely on them certainly makes your work faster. Now, find the size of each interior and exterior angle of a regular 12-sided polygon. You'll see here there are some formulas. Now, the exterior angle is fine because right, we just divide 360 by the number of sides. So, first part. Actually, I don't think I need an explanation here. I think if I just say 360 over 12 equals 360 divided by 12, is it 30 degrees? I think it must be. Therefore, the external angles, exterior. Okay, so the exterior angles are 30 degrees. We also want to find the size of the interior angles. Now there is a formula here as well. What we do is we subtract, we subtract 2 from the number of sides, and we multiply that by 180 and then divide by the number of sides. Now I've lost my pen again. Come on, pen, where are you? Here we go. That's not it. Here we go. So now I'm going to say that 180 times, now 12 minus 2 is 10, and we divide that by the number of sides. Okay, now I'm going to try to get my calculator here because it is 5 in the morning and I'm fairly tired. So where are we at here? Said it was 180. Oops. 180 times 10 and we'll divide that by 12 and we get 150 equals 150 degrees, and I went to an awful lot of work there when really it's quite simple. It's quite straightforward that the exterior and the interior angles are supplementary. Okay, think of, right, actually have we got a diagram back here? No, we don't. If I just draw a little part of it here. Right, if I have something like this going on, this is my interior angle, this is my exterior angle. Now we know the sum of the exterior angles for a convex, and all regular polygons will be convex. The sum of the exterior angles, right, they sort of manage to get at these lines if we sort of consider the direction of them, and eventually it turns all the way back around to where it came from. So they add up to 360. We divide it by the number 30. So this part here, my interior angle, is simply 180 minus my last answer. Right. Anyway, that is it for 7b. There are lots of exercises to work through. The examples that I do are very much only an example, and there'll be all sorts of other things to do. You will need to complete as many of these as possible and be checking them with me. Okay, I'll see you in class. Hope you enjoy.